Question time with the Cosmic Kids.
Hey kids, what are the tiny pieces of you that are 13 billion years old and were once tiny pieces of the last T-Rex and Albert Einstein?
What? That is crazy. No way.
Yes way.
Okay, please explain it.
First, the answer is that the tiny pieces of you are carbon atoms. And here is how you have carbon atoms that were once in a T-Rex. The T-Rex has carbon atoms in its body that can be converted to carbon dioxide gas to produce its energy for living and moving. The carbon dioxide gas is exhaled when the T-Rex breathes. The carbon dioxide molecule is made up of one carbon atom and two oxygen atoms.
The carbon dioxide gas becomes part of the atmosphere.
We are showing them big so you can see them, but they are really, really tiny. Over a long time, lots of those carbon dioxide molecules go into the ocean and other places. But lots of the original T-Rex carbon atoms are still in the atmosphere today as carbon dioxide. This is possible because carbon atoms live for billions and billions of years. And in the present time, some of it gets absorbed by trees and made into apples and other things to eat. Then you eat one of those apples.
Okay, I love apples.
And voila, you now have dinosaur carbon atoms in you.
Cool, I can feel them now. Rawr!
Wow, did I just eat a lot of T-Rex carbons?
Yes, Nettie, you probably ate over 500 billion T-Rex carbon atoms in just one bite. And believe it or not, you have over 5,000 trillion carbon atoms in you that were once in just one T-Rex.
We must have trillions of carbon atoms from lots of other animals too.
Hey VC, you could even have some of my carbon atoms.
Right and right.
Okay, now tell us why the carbon atom piece of me is 13 billion years old.
That is because carbon atoms live for billions of years and were formed billions and billions of years ago. Let's teleport back to the cosmic egg and do some time traveling to see when they were created.
Wow, I love teleporting.
First, let's go back to the Big Bang.
Okay, I will set the time for 13.8 billion years ago.
What size should we be?
Nettie, set us to quark size.
Wow, this is cool. We are at the Big Bang.
Yes, and what we see are quarks, the first particles in the universe.
Are we made out of those quarks?
Correct. But first, the quarks are assembled into protons and neutrons that make up the nuclei of your atoms.
When did the atoms get made?
We need to go forward 300,000 years to see the first atoms form.
Yes, sir. I am on it.
This is 300,000 years after the Big Bang.
Take a look at your periodic table. It'll show you what atoms formed.
Hydrogen and helium atoms are forming. A tiny bit of lithium too.
But what about heavier atoms like carbon and oxygen?
That didn't happen for hundreds of millions of years. Let's change to star size and go forward in time and investigate.
Now it's 300 million years after the Big Bang. Oh look, it's beautiful.
Stars are forming from all the hydrogen and helium gas.
Let's go forward in time to see what happens to the stars.
Now it is 500 million years after the Big Bang. Wow, that star is exploding.
Right, Nettie. It is called a supernova. It happens when all the star's hydrogen burns up.
And look, about half of the heavier atoms were produced in the supernova, including carbon and oxygen.
Did any of my atoms come from that star?
And mine too?
Probably. There are only a billion trillion stars in today's universe. You would need to get about 1 million carbon atoms from each star to get enough for your body.
Now look, there are two tiny little stars circling each other.
Wow, now they are merging. And now they are exploding.
That is the merging of two neutron stars. And explosions like that and supernovas of stars 5 billion years later produce the rest of the atoms that are on Earth. Well, now that you know the story of Stardust, you can see other science videos about atoms.
Yeah, you can find them on our Stardust Mystery YouTube channel.
And I have a starring role in some of them.